Hello and welcome to part 3 of my eclipse episode. You might be thinking, what? Another episode about that eclipse? But it was the best day of my life so far, and there was just too much to fit into the last episode. So I'm checking in before we switch back to all the good stuff that was too big for part 2. Just to recap so far, we've covered what an eclipse is and what causes them in Eclipse Part 1, and then we covered the eclipse from 8th of April from Waco, Texas in Eclipse Part 2. Now it's time to discover more of the science around an eclipse. Some of the other questions scientists will be working on during the eclipse are very interesting and can help further human understanding of things that can be very difficult to measure because of how hot and powerful the sun is. Scientists will be taking readings of radio transmissions to help understand space weather, which is the term used to describe energy from the sun that can affect the technology we use on Earth, things like cables and electricity grids. The drop in these readings as the moon crosses the sun will be used to more accurately predict future space weather. They will be using the moon silhouette to more accurately measure the size of the sun. Because did you know that although we have a measurement for the sun, it's predicted that it's a few hundred miles off. This is unlike the moon, which has been measured very accurately using lasers bounced off its surface back to Earth and is accurate in just 10 meters. Scientists, of course, will be looking at the sun's corona. There's still a big question that has remained unanswered about why the corona is hotter than the photosphere, the outer layer of the sun. A June eclipse is the best time to study the corona. Solar researchers will be able to have a better look at the chemical elements within the corona when there's much less light interference on the telescope. This could lead to a better understanding of temperature variation within the sun's outer atmosphere. Dr. Mark Clanton, who is the Director of Astrophysics at NASA in Washington, D.C., told us a little bit about it. Here it is.
So today's eclipse is really a big event for people who study the sun. It's an opportunity to get a very clear picture of the atmosphere around the sun. And Earth scientists are also, using this to understand what happens, when you have a very small change in temperature, the impact on the atmosphere and the different layers in the atmosphere. Even on a day like this, when you kind of struggle to see the bits of blue sky, sometimes it kind of clears around the sun during totality, just because you have that sudden cooling and has an effect on the upper atmosphere. And I actually saw that last time in 2017.
This is definitely what we saw, and we're very lucky to have the clouds clear around in the sun right at totality, so we had a perfect view. Well, it will be exciting when we can see some of the findings from the research come through. I had a chat with Dr. Ma, and when I asked him if he could visit anywhere in space, he told me he'd visit a planetary system called TRAPPIST-1. That's a star about 40 light years away. It has 7 planets around it. He would like to know if there was life on some of those planets. Searching for life on other planets is what got Dr. Mark interested in astronomy. On the day of the eclipse, I was lucky enough to talk to Dr. Lauren Swint Matthews. Here's some of the chat with her. She's very clever.
Okay, so physics, I teach everything from how you figure out how a block slides down a ramp to how you form planets. That's what I really got interested in, is how you form planets. Do you know the planets in the solar system?
Mercury,
Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune.
Pluto used to be a planet, but it's not anymore.
That's right. When I was your age, Pluto was still a planet. And then we demoted it to a dwarf planet.
In 2006.
I'm glad you remember that year. Wow. So what would you say is the main difference between Mercury, Venus, Earth, and Mars and the planets like Jupiter and Saturn and Uranus and Neptune?
The difference is the planet type.
Yes.
But Mercury, Venus, Earth, and Mars are all rocky planets, and Jupiter, Saturn, Uranus, Neptune are gas giants.
That's right.
And the size, the rocky planets are small and the gas giants are huge.
Very, very different. That's right. So that's when I got started studying physics. That's one of the questions I had, is why do we have these small rocky planets close to the sun and then these giant gas planets that are far away from the sun? So what I was looking at is something called dusty plasma. Do you know what plasma is?
It's hot.
It's very hot, but an interesting thing is it can also be cold. So plasma is an ionized gas, and the whole universe is full of plasma. Actually, 99.99% of the visible universe is plasma. That's a lot of plasma. So if you have plasma everywhere, and you have dust everywhere, do you have dust under your bed? Do you have dust bunnies in Australia? So I study how you make cosmic dust bunnies that would orbit a newly formed star. So I look at how the plasma charges up the dust, and then the dust, when it tries to stick together, it will repel them because they're charged up. But if
What
you
does
get
repel mean?
repel means that you've got two dust particles and they're attracting each other, and then they'll turn around and go back. Have you ever played with magnets? And you know how if you try to push one magnet with another magnet, it'll move away? So that's
Except if you connect the plus with the
That's right.
minus.
If you a magnet, if you turn it around the other way, they'll attract. So for the charged dust bunnies, they can be positive or negative.
Ooh.
Yes. And if you have two negatives, they repel. But if you have a positive and a negative, they attract. So on the dust bunnies, the charges can rearrange and you can get positive and negative. So as they come in, they actually rotate. And then when they collide, they can make fluffier dust bunnies. And that helps you get started on making planets faster.
If you could go anywhere, where would you go?
That is a tough question. Now, you have to think about what would be the most interesting thing you can see, or you're imagining that we can get there faster than the speed of light. So we don't have to worry about the travel time. You know, it takes 3 days to get to the moon, and you're packed in a space the size of your car. So do you want to spend 3 days in your car traveling to the moon?
Not a car, a rocket.
Yes, but rockets are not that big. The inside of the rocket where the astronauts are, or the cosmonauts are, is not much bigger than the inside of your car. You're actually pretty packed in there.
Rockets are much bigger than cars.
Yes, because all of that extra space in the rocket is full of fuel. That's how much, so your rocket's this big, all of this is fuel, and then this little bit right here at the end, that's where the astronauts are. That's all that gets to end up in space. Yeah, well, I would actually just really like to go to the International Space Station because it's close.
It's close. It's
Yeah.
only 250 miles away from here.
Yeah, so if we could drive there in our car, we could get there in 4 or 5 hours
In the car.
in the car if we could drive. But our cars can't drive up to the space station. That would definitely be worth it to go and visit the International Space Station. And then you get to float around in microgravity.
Guess how long the International Space Station is?
It's longer than, well, the solar panels are longer than a couple of football fields.
Thank you so much.
You are so very welcome. I've enjoyed talking to you.
I was also very lucky to talk to Dr. Tyler Ritchie Yao. She did a great talk to all the people at the eclipse event about the sun and how it shapes our planet and also the other planets in our solar system. Now here's us having a little chat while we're still waiting for totality. Do you know anything that's beyond the universe?
Ooh, that's beyond the universe. I don't think we really know that right now, but that's a really good question because there could be other universes, but I don't think we really have the idea to tell now.
What is your favourite thing to learn about and study?
I really like the idea of trying to find life on another planet. And so what I actually do is I look at the stars that are out there and say, okay, can this star have a planet around it that can support life? And we look at the UV radiation, like, you know, the stuff that comes and gives us the sunburn. And so we look at that and say, okay, there's a lot of this, so we're probably not going to find life like ours on those planets.
If you can go anywhere in space, where would you go?
Ooh, that's a really good question. I'd probably go visit some exoplanets, which are just any planets outside of our solar system. Yeah, so I think any one of those, because I think we kind of know a little bit about ours, but we don't really know too much about the exoplanets. And so we're only able to see some light from them. We can't go and touch them, see what they're made out of. Let's see, there's one called HD 189733b, and it rains glass sideways on that planet. That would be kind of weird to be there, right? Can you imagine? You have to be a ninja.
Any more exoplanets you know?
See, there's some planets from the Kelt survey that are super, super hot. They're like magma. They're all lava planets.
Thanks for chatting to you.
Okay.
I'm waiting for the eclipse.
Are you excited for the eclipse?
Well, to finish up, let's talk about some of the other interesting research to do with the animals during the eclipse. Researchers, zookeepers and citizen scientists got ready to absorb many of the changes in normal animal behavior. Did you know that halfway through the eclipse, the cages in Arizona stopped chirping? Lions in a zoo in Buffalo roared right before totality, and ostriches in Ohio start returning to their night enclosure and roosting to get ready for sleep. Then, when totality passed and the light returned, they simply went back to their daytime activities. Flamingos in Fort Worth, Texas bunched up together and started marching and honking, and some poor gorillas in the same zoo thought they missed their dinner and were seemingly a bit confused and frustrated. That's crazy! Thanks so much for watching another episode of Wes Knows. I hope you've found some interesting facts today. And as always, like, share, and subscribe to my channel. Bye bye! Thanks for watching.